Hello everyone. In this tutorial, we are going to integrate this definite integral by partial fractions. We have the function 2 divided by t to the power of 3 multiplied by t plus 1 with respect to t. First of all, I would like to resolve this 2 divided by t to the power of 3 multiplied by t plus 1 into its partial fractions. So the function is 2 divided by t to the power of 3 multiplied by t plus 1. How can we resolve this into partial fractions? You have to always consider the denominator. We have two different factors here. All right, but this is repeated, right? T times t, which is t to the power of 3. So I would like to start with this one. So we have a constant divided by t without power plus another constant divided by t to the second power plus another constant divided by t to the power of 3. We are done with this one. Then plus another constant divided by the second factor, which is t plus 1. Now I would like to multiply every single term by this denominator. If you do that to the left, you will be left with only 2. This is equal to, take this and multiply by this, only 1t will reduce here. We still have t squared times t plus 1, then multiplied by a. All right? Then we do the same thing here. T to the second power will cancel 2 t's here, leaving a single t. Then multiply by t plus 1, then times b. Plus, moving here, t to the power of 3 will cancel the whole of this, leaving only t plus 1 multiplied by c. And lastly, the whole of this, if multiplied by this, t plus 1 will cancel, leaving t to the power of 3 times d. So we have d times t to the power of 3. Let us expand. We have t squared times t is t to the power of 3 times a is a t to the power of 3. Then t squared times 1 is still t squared times a is a t squared. Plus t times t is t squared times b is b t squared. T times 1 is t times b is bt. Moving on, we have c times t is ct. C times 1 is c. Then lastly, we have dt to the power of 3. Let us collect the like terms, thus with t to the power of 3 together. We have this and that, but we can factor out t to the power of 3. So we have a plus d multiplied by t to the power of 3. Then thus with power of 2, we have one here, we have the other one here. We equally factor out t squared. We have a plus b inside multiplied by t squared. Then thus with t, we have one here, we have the other one here, plus b plus c times t. And thus with constant, thus without t, I think we only have one, right? Which is c here, plus c. Remember, to the left, we still have 2. Okay. Do we have any term with t to the power of 3 to the left? No. Therefore, the whole coefficient here will be equal to 0. A plus d is equal to 0. We do not have any term with t squared to the left. Therefore, a plus b will be equal to 0 as well. Likewise, this one, b plus c will be equal to 0. But c is constant and we have a constant here. Hence, c is equal to 2. So now we're going to start back substituting. If you take this, you plug it back here. Because c is 2, we have b plus 2 equal to 0, which implies that b is equal to negative 2, right? Then we take b and plug it here so that we have a minus 2, because b is minus 2, equal to 0, which implies that a is equal to what? is equal to positive 2 as negative 2 crosses over. And lastly, we can take a and plug it into the first equation where we have a plus d, but a is already 2. So we have 2 plus d is 0, which implies that d is negative 2. D is equal to negative 2. All right. So we have A, B, C, and D. We're going to back substitute them here. Exactly here. So let me just copy this equation. So now let us replace A, B, C, and D with their values. You can see that A is 2. So let me place 2 here. B is negative 2. So I'm going to change this to negative 2. C is positive 2. You can see that here. So we have positive 2. And D is negative 2. So this becomes negative 2. All right. But remember, we are integrating this, right? Instead of integrating this, we are now going to integrate the whole of this. All right. But I'm going to integrate them term by term. Let me show you. This implies that the integral of 2 divided by t to the power of 3 multiplied by t plus 1 with respect to t is now equal to the integral of this one, which I believe I can factor out the 2, bring it outside, times the integral of what? Just 1 divided by t dt minus, do the same thing here, I'll factor out 2, multiply by the integral of 1 divided by t squared. Moving on, we have 2 multiplied by the integral of 1 divided by t to the power of 3, then minus 2 again, multiplied by the integral of 1 divided by t plus 1. So let's start with the first one here. We have this to be equal to 2 times the integral of this. Just observe that the derivative of t is 1. So whenever the derivative of the bottom is exactly as the top, then the whole integral of that function will be the natural log of the absolute value of the denominator, which is t. Yes, we are done with this one. Then moving to the next one, we have minus 2 times the integral of 1 divided by t squared. 1 divided by t squared, remember, it can be written as t raised to the power of negative 2. So to integrate this, you can simply add 1 here and also divide by what? Negative 2 plus 1. This will give us t to the negative 1 divided by negative 1, or simply negative t to the negative 1. But t to the negative 1 is also the same thing as what? 1 divided by t, which implies that the whole of this is equal to negative 1 over t. Okay? But since we have a negative here, once they multiply, it becomes positive. So let me just change this to positive 2 times 1 divided by t. 1 divided by t. We are done with this one. Then we move to the next one. We have plus 2. The integral of this one, it can also be written as what? T to the negative 3. T to the negative 3. If you add 1 to the exponent, it becomes what? Negative 2. You have to divide by negative 2 as well. Divide by negative 2. You can drop this down so that the exponent becomes, what do we call it? Positive t squared. But remember, we still have 2 here, right? This particular 2, they will multiply. So the whole of that integral will be this one. It has a minus, so this will become minus 2 times the whole of 1 divided by 2t squared. I know that this will cancel this, but let me do that in the next step. Then lastly, we have minus 2. The integral of this one, just observe that the derivative of the bottom will give you 1, and we have 1 to the top. So this will be the natural log of the absolute value of the denominator. Don't add the constant of integration because remember we have a limit. The limit is what? From 1 to 2. So we are integrating from 1 to 2. Instead, we have from 1 down to 2. So now let us substitute our boundaries. This is equal to, let me start with the upper limit, which is 2. Wherever we have t, we are going to replace it with 2. So this is 2 multiplied by natural log of 2, right? Plus, you know, this is the same thing as 2 divided by t, but t is 2. So we have 2 divided by 2 here. Minus, I know that this and this will cancel. Minus 1 divided by t squared. And t squared is what? 2 squared. Then minus 2 times natural log of what? 2 plus 1, which is 3. Okay, then remember we have to subtract the lower limit minus the lower limit, which is 1. Wherever I have t, we are going to replace it with 1. You can see that this is natural log of 1, but log of 1 to any base is 0, times 2 is 0, so the whole of this will be 0 if you substitute 1. Then here we have 2 divided by t, but t is 1. So we have 2 divided by 1. Then here we have minus. This is 1 divided by 1 squared. 1 divided by 1 squared. Minus 2 times natural log of what? 1 plus 1 is 2. So we only need to simplify. Remember that this 2 can serve as a power of this 2 according to one of the laws of logarithm. And 2 to the power of 2 is 4. So this is natural log of 4. This is 1. This is 1 over 4 minus 1 over 4 minus this 2 can serve as the power of 3, and 3 to the power of 2 is 9. So we have natural log of 9 minus, inside we have 2 divided by 1 is 2 minus, this is 1 as well, the minus natural log of 4, because this 2 can serve as a power of 2 here. This is natural log of 4 minus natural log of 9, bringing this together. Then 1 minus 1 over 4 will give us 3 divided by 4. 3 divided by 4. Then from the other bracket, we have 2 minus 1 is 1, then minus natural log of 4. If you expand this bracket, every sign will change. So we have natural log of 4 minus natural log of 9 plus 3 divided by 4 minus 1 plus natural log of 4. This and this are like terms, so we have 2 of them, 2 natural log of 4 minus natural log of 9. Then this, if you subtract, you're going to get minus 1 over 4, minus 1 over 4. This will be power of this, so 4 to the power of 2 is 16. So we have natural log of 16 minus natural log of 9 minus 1 over 4. And the last step, since we're subtracting, we can divide the arguments according to one of the laws of logarithm. So this is natural log of what? 16 divided by 9, the minus 1 divided by 4. Do we have any common factor that can divide here? Yeah, we do not have any. And hence, this is said to be the solution to this problem. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.